Hello and welcome back to Kerbal Space Programming, where in the last episode, our Kerbals ceased to receive telemetry from our first lunar flyby probe. But not to be deterred, they sent another one. Slightly modified, we've moved the mystery goo up, and we have added an additional dish satellite so that we can maintain contact for at least some of the time when this thing is close to orbit. Now, I've gone ahead and adjusted the ascent profile very, very slightly, not by much and not even worth kind of going into, but we can see this is burning up and getting its way closely into orbit, ditching its boosters and getting all the way up there, trying not to kind of duplicate stuff that we've covered in the previous episodes. But this one does make it all the way up to orbit, and we are hopeful. We've got some additional solar panels to try and make sure that we've got the charge to maintain this dish antenna, which is going to require significantly more power. But we are just coasting our way up to Apoapsis, ready to fly by the moon again and actually return some science this time. And there we go, finishing our circularization, burning and burning, waiting to ditch this stage and let it return back until finally we manage to achieve a successful orbit soon. Come on, get there, there we go. All right, orbited. So before we jump into our transfer burn to the moon, the Kerbals have been hard at work writing some orbital functions to help us do this in a bit more useful way. And I'm going to step through these really quickly. We've got this function. Actually, before I do that, we need to talk about the modulo operator. I glossed over it briefly in the last episode, but we're going to dive into it. Let's open up a Ruby terminal. So this is not KerboScript. This is another programming language called Ruby. And we know our standard math, right? We've got, 12 plus 12, 12 minus 12, 12 times 12, and 12 divided by 12. Basic arithmetic that all of us learn at some point in our lives, hopefully. There's another operator that is used a lot in programming, but doesn't often come up when you are learning your arithmetic, and this is called the modulo operator. I'm going to type in 18 and say %, 12. Let me enter, and we see we get a result of 6. Now what this is doing is it is giving us the remainder of what happens if we divide 18 by 12. So we take 12 out of that, and that leaves us with 6. So this would be, if you're looking at 24-hour time, it's 1800 hours. Well, then it's 6 o'clock p.m., right? We're just going to remove as many 12s as we possibly can. And this is something that you'll find in a bunch of different programming languages, so the implementation may be a little bit different. For example, well, let's say 18 mod 5. And we get 3. It's just going to pull out as many 5s as it possibly can, and we're getting the remainder. Now, there is something that differs between how these things can be implemented. Let's say that we take -3 mod 5. What is that going to do? Well, the answer in Ruby is that we get 2. What it's going to do is it's going to say, okay, you're trying to pull out positive 5s, so we're just going to make sure that this is above 0, and we're going to either add or remove 5s until we get a value, okay? What happens, though, if we say -3 mod -5? Well, then we get -3, because it can't pull out any -5s, and that gets confusing. Now, the thing in KerboScript is that if we say something like -12 mod 5, which in Ruby is going to give us 3. It's going to just add 5s until it's a positive value and can't, remove or add 5s anymore. But in KerboScript, what we'll end up with is -2. It's just going to get it up close, but it's not going to bump it over 0. So this is something that we've got to kind of keep an eye out for. And if this was the case, well, that's fine. We can say here, we'll say, if we got -2, we say, okay, and then +5, just to make sure that it's positive. And then we get our value of 3 that we would normally expect from the modulo operator. So this is something that we get in many programming languages in addition to kind of your basic arithmetic. So with that said, let's jump back over into our function. Okay. So this first function is longitude 2 degrees, and this is just a helper function. It's going to take an input longitude. We're going to say mod 360 and mod the longitude plus 360, and we're going to wrap it by 360. So this is effectively the same as long plus 360. Oops. Oh, come on, Kevin. Mod 360. This sign is usually used to mean the modulo operator in most languages, but in this case, in KerboScript, we have a mod function. So what this is going to do is it's going to say we're going to take this value, which can be from negative 180 to 180, and we're going to add 360 to it. So now it becomes 180 to, whoa, what is that? What is that? 540. Yes. Right? So now we've got a range from 180 to 540. And then we're just going to say pull out as many 360s as you possibly can. And this will get us a value between 0 and 360, which is just going to make things a little bit easier for us to deal with than trying to worry about these negative numbers. So we can go ahead and say longitude 2 degrees and pull in, negative 180, and we'll get out a value between 0 to 360. Next thing we have here is this thing called orbitable. So there are two different ways to get access to objects to get access to other ships or orbiting bodies in Kerbal script. We can say body moon, or we can say vessel Omnisat 1. And there are a couple of functions where it'd be great to say, I just want to know what our angle is relative to this thing, and I don't want to tell you if it's a body or a vessel. So what this function is going to do is it's going to say list all of the possible targets, which is going to be all of the vessels, not the moon, not Kerbal, none of that. And it's just going to say for each of these, if the name matches the name, then we're going to return the vessel. And if it's not, then we're going to assume it's a body. So we can say, give us the orbitable moon, and it would be, give us some target angle or something like that. But we could also then jump in here and say Omnisat 1, and then do the same thing. So we don't have to worry about specifying whether we're talking about another ship or whether we're talking about a planet or moon. And then the last function here is going to give us the target angle relative to our current ship. So we take a parameter, and this is going to be the target, and we're going to grab that orbitable here. So we're going to take the orbitable, and we've got to kind of look at this thing from the inside out, because we've got a couple of functions here. So we've got actually two functions. We've got LNG 2 degrees and then orbitable. So we're going to get the orbital for the target. So this may be like Omnisat 1, or it may be the moon. In this case, we're going to be passing it the moon. So we'll say, get me the orbitable that is the moon. And then I want to grab its longitude, which is going to give us negative 180 to 180. And then I'm going to turn that into a value from 0 to 360. Next, I'm going to get the 0 to 360 value for our current ship's longitude. And then I'm going to add 360 to make sure that this value doesn't end up being negative, and then I'm going to mod it, take the remainder by dividing it by 360. So this will get us, we can say target angle, angle, moon. We can print that out, and it'll give us a value from 0 to 360. It'll tell us how far ahead of us in degrees the target is. But we could also do this with something like Omnisat 1. So the idea is that we're making this into a library function called orbit, and we can, then use these functions throughout our scripts and be able to reuse these between various missions. So let's take a look at what we've changed in our actual transfer to the moon. Okay, so we've made a couple of changes. First, we're going to say we're downloading some additional important files. We're going to download this lunarflyby2.startup.ks file, which we'll jump into in a second, and then we'll download this orbit.ks file. We're going to rename this flyby startup thing to startup.ks. Remember that in our boot script, that's a file that's going to run if we can't get additional instructions. It'll go, okay, I have a startup script. I'll go ahead and run that. Then we're going to run our orbit script so that we have those functions available. Next, and this is pretty similar to stuff that we had in the previous episode, we're trying to go to the moon. We've got a function called ish that's going to tell us if two numbers are close to each other. Now we're going to wait until our target angle from the moon. Remember, we had this ugly function before. We've got that target angle function in our orbit library. We just say, okay, we want to wait until the target angle of the moon is 135, and we said ish. We want to make sure that it's close to that, but it doesn't need to be 100% exact. And then I've also, just for the purposes of being able to time warp, I said, go ahead and print it out and wait until this is happening so I can keep an eye on how far away we are, so I can time warp ahead until it gets close. Now we've got our Munu transfer, and this is exactly the same as in the last episode. We're going to set forward to prograde, lock the steering, wait 10 seconds, throttle up, wait until our apoapsis is greater than the moon's apoapsis, and then we'll throttle down, and we're going to toggle the brakes. Next, we're going to wait until we are in the sphere of influence of the moon. We're checking the current orbit and the body and its name. We're saying, okay, as long as we're not around Kerbal, then we can continue. And instead of just flying by and doing science, we are going to wait until we're close to the periapsis. Now periapsis refers to the periapsis around the moon. We're going to lock our steering to retrograde, so the opposite direction of our orbit, and then we're going to throttle up. So this is actually going to put us in orbit around the moon. We're not just going to fly by it. We are going to orbit this thing. So we're going to wait until our apoapsis is greater than 0 and that the apoapsis is less than the moon's sphere of influence radius minus the moon's radius minus 20,000. And this is a little bit complex. Let me break it down. First off, if we don't have an apoapsis, because remember before we were flying by, there wasn't a highest point in our orbit, well then the apoapsis that we get is going to be negative. So we just want to make sure that we actually have an apoapsis. So that's what this first bit does. This second bit, this and, is going to say, okay, our apoapsis has to be less than the SOI, the sphere of influence radius of the moon, and this is based on the exact center of the moon. Not the moon's, what our altitude actually is. So remember when we were orbiting Kerbal, our apoapsis was, 70,000. But really, that's 70,000 from sea level of Kerbal. So we have to be careful because, there's an additional amount of space between the center of Kerbal and the value that we actually get. So we're also going to subtract the moon's radius, and this is from the center to sea level. And then we're just going to add 20,000 to make sure that we're not so close to outside of the range of the moon that we end up in trouble. And then we'll throttle down, we'll say we are in orbit, and then we will be good to go. So the last thing that we need to talk about is this startup script. So our dish is going to take a lot of power, and there's a real risk that if we leave it enabled, we will drain ourselves and the ship will end up in trouble because the CPU will have to shut down. There won't be enough electric charge. So what we've got here is I said ship electric charge is less than 200. Well, then we're going to toggle the brakes. This is going to disable our long-range dish antenna. Okay, so now the second thing is we're going to check if it's over 800. I think we have a capacity of around 1,000. So if we've got a lot of charge, then we're going to say, okay, we're going to set P to ship part named medium dish antenna. This is some stuff to do with remote tech. We're going to get the module and we're going to set its target to Kerbal. This is all kind of remote techy stuff. It's not super easy to explain. This is really just sort of a kind of a cut and paste based on how that works. But we need to actually not only say turn on the dish, which we're going to do with toggle RCS, but we've actually got to point it at the right thing as well. Because when we're dealing with these long-range antennas, you actually have to point it in a particular direction, and then you will get a particular field of view. And as long as we are able to point this at Kerbal, then we will be able to get a direct connection. Then we're going to wait 10 seconds and reboot. So if we don't have new instructions, it'll continue running the startup script, and so it'll make sure that if we ever run too low, it'll turn off the dish, and then once we get back up to greater than 800, well then it'll go ahead and turn it on again. So with that said, let us jump over and get ourselves to the moon. And after uploading those new instructions, we can see our craft beginning its lunar insertion, or lunar transfer burn, rather. We can see the moon is ahead of us. We're going at pretty much the same angle. We can see this orbit slowly boosting up, ready to encounter the moon again this time. And once we get there, we'll go ahead and circularize and see if we can find anything of the first lunar probe. Though we are not optimistic, because, the omniscient among us suspect that something may have gone wrong with the last mission. But meanwhile, back on Kerbal, we have to get some additional funds. We are going to go ahead and upgrade mission control, which will let us grab some additional contracts all at once, so that we don't run out of achievable contracts while we are out heading to the moon again. This will let us accept 7 active contracts. So we'll go ahead and click into the Mission Control Center and look at what we can do. So we've got ferries and tourists and all of these things. This is going to give us some funds and perhaps some science. We can see there's completion funds and advance and all that sort of stuff. So we're going to go ahead and grab up a bunch of these. See, some of these do have science because we're testing particular parts, and we can pick up to 7 of these, which is great. You see there's a long duration here, so we can actually, once we've accepted this, we have 5 years to actually complete it. So there's not a huge penalty for us just grabbing a whole bunch of these and saying, we'll do it later. So let's see, position a satellite in polar orbit. That seems like something we can do. Let's go ahead and grab that. and test the launch escape system. That's going to give us science, and let's see, more science data from around the moon. That we can probably get right now, because we've got a probe ready to go ahead and do that. That's just fetch some science from around the moon. That's perfect. And let's see, we'll just grab some more of these rescue people, which is going to be great because it means that we can actually, they become astronauts in our system, which, you know, who needs astronauts when we've got programming? But, you know, could be useful. And we'll just grab up one more, and that should do us. But back to our Lunar Probe number 2, creeping up on the moon and ready to, there we go, enter the sphere of influence. Now we just have to wait until we get to the periapsis. We're going to time warp and be a little careful to make sure we don't skip over it. We'll keep an eye on the nav ball. And there we go. We are ready to circularize and bring ourselves into a lunar orbit, at which point our dish antenna should deploy, and we should be ready for new instructions. There we go, our dish antenna. And we are ready to go. And we've got a connection. Huzzah! And jumping back to our craft in orbit, we have transmitted a single command, and that is toggle the lights, which should mean do science, please. And there we go. We get a whole bunch of science because it's going to activate all of our experiments. We get the material study, which says the high radiation environment caused a few of the samples to glow. It'd be fun to paint the rocket with this. Indeed, it may be. But let's go ahead and keep that data. That's going to give us 50 science. That is wonderful. And we have a temperature scan measuring space seems to be quite impossible. No matter, it's as if there's no hot or cold except the spacecraft and the thermometer, which is going to give the R&D guys something to think about. We will transmit that because we can spam our thermometer science, so we'll actually transmit that back to Kerbal. And we've got mystery goo, which feels right at home here. And the other goo also feels right at home here, so we will keep all of those. And now we're going to transmit the very same signal again. Actually, you know what? I misspoke. We don't want to just transmit the signal, but we actually want to let this thing go ahead and deorbit. Now, unfortunately, there's not an easy way, as far as I can tell, to determine when we are at the right part of our orbit to begin expanding and get out of orbit. What we want to end up doing is actually burning when we are about here in our orbit, because then we will end up going opposite to the orbit of the moon, which will mean that we will fall closer to Kerbal and not boost our orbit up. But what we are going to have to do is figure out, how do we know when we are there? And as near as I can tell, we can't figure out the longitude of us relative to the moon, relative to our longitude and the moon's longitude relative to Kerbal. So I think what we are going to have to do is kind of estimate. I'm going to say that we are, so if we were to draw a line, so this is going to be 180 degrees, right? And then I'm going to say that we are an additional probably 30 degrees behind that. So I'm going to say wait until our longitude is, let's see, 180 plus 30 is 210 degrees further along, and then go ahead and start our deorbit. So let's jump over and write a script to do that. Okay, so first thing that we're going to want to do is toggle the lights again, because we transmitted our thermometer, but it would be great to get even more science, so we'll toggle it again and we'll actually save the data this time. We'll run our orbit KS script, which gives us that longitude 2 degrees function, and we're going to set our original angle to the ship's current longitude. So that's where it is right now. Then we'll lock our current angle. We're going to lock instead of set. So this means that any time that we look at this, it's going to go ahead and run this to check. We're going to lock it to the same thing. So original angle will be what our angle is right now, and then current angle will be what our angle is whenever it looks at it. I'm going to go ahead and say until the mod, so we're taking the difference in terms of 360, is greater than 210. So what we want to make sure is that we are waiting until we are 210 degrees further along in our orbit than we currently are. And this is just stuff that I end up using to make it easier to time warp and not have to record, hour-long videos just to get the stuff that we want. So I'm going to print out what the current angle is that we've got, and we'll wait a second. Next, we will try and return to Kerbal. And we should probably make this script more optimistic, but we'll lock our direction. We'll set our direction to prograde and then lock the steering to that direction. So we're going to expand our orbit out until we are no longer in the sphere of influence of the moon. We'll throttle up and we'll wait until our apoapsis is less than 0. Remember, if there isn't an apoapsis, a highest part of our orbit, then it's a negative value, what we get back. So again, I'm doing some printout stuff to make it easy to time warp. And then once we have no apoapsis, that means we are going to escape the moon. So we can go ahead and throttle down. Let's run it. And returning to our vessel with that script written, we simply have to wait until it picks up its new script, at which point it will toggle the science yet again. And there we go, we get a temperature scan, and we see we can't transmit this because we will not be able to recover much, but we can in fact save it. And again, still measuring the temperature of space seems to be quite impossible. So we will keep that, and now it's just a matter of warping around the moon until we get to the right angle to return to Kerbal. And let's just do some more warping. Oh, there we go. Now we're rotating. This is the nice thing about not having a range. We've just said wait until it's greater than that. And we will lock over there and start our ejection burn. So we can see, yep, now we are... And this is a fun thing about how these orbits look. It looks like we are going to go way out into space, but as soon as we get out of range of the moon, our orbit should correct itself a little bit. Of course, we will lose signal to Kerbal as soon as we start to fly away. But with that, it is our last chance to say goodbye to the moon. Goodbye, moon, as it continues to fly around behind us. Goodbye, moon. And because we have run low on power, it looks like... Let's jump this back open. Yep, see we are... Oh, now that's interesting. It did... Oh, there we go. Now we've got power. Must have been just when we were in the moon's shadow, our electric charge went down enough that it decided it had to undeploy this ComSat and let us give us some time to recharge. But that is a nice feature for us to have. Let's jump back out to our map. Okay, we're still well within the sphere of influence. Let's jump out. There we go. All right. So now we are on a new orbit, which will at least get us, I think it'll get us here faster than the moon. I sincerely hope so. And we're going to need to spend a lot of energy to get this periapsis down. So we're going to want to go ahead and write a script to do that. But of course, we won't be able to transmit that when we have a line of sight connection to the space center. So the Earth is going to have to, or the Kerbal is going to have to rotate beneath us. But there we go. We have a connection. Let us write our deorbit script. Okay, so now it is time to write our deorbit script. We're going to bring our periaps into the atmosphere, and the first thing that we're going to do is delete this startup script that is turning our dish off and on based on the electrical charge. So we will disable the dish by toggling the brakes, and we'll delete this startup script. So now whenever the boot script runs, it's not going to find it. Then we're going to wait until our ETA to apoapsis is less than 20. We'll set the direction to retrograde and lock our steering, and then we will fire. Once we get our periapsis into the atmosphere, we'll throttle down. We'll lock our steering to retrograde to make sure that we hit the atmosphere engine first. We'll wait until we're close to the periapsis, and then we'll burn out all of our remaining fuel. We'll set our previous thrust to max thrust and do this stuff that we used to detect when we ran when the engine burnt out last time. And then we'll wait 10 seconds, print that we're staging, and stage. And then we should be able to get ourselves back to Kerbal. And with that script written, we can jump back over to our craft and keep an eye on it. Wait, and as soon as it gets its signal, it should disable this dish because we have no more need of it. And there we go. It is down, and now it is just a question of warping until we make our way up to apoapsis, which will take a while because we are far away from Kerbal. You see, it is rotating quite rapidly beneath us, but we are moving much slower relative to that. Thankfully, the moon is much further behind us this time, so we run no risk of colliding into the moon on our way back to Kerbal. So let us just coast ahead until we get to our apoapsis. Almost there, come on. Got to be very careful not to time warp too far past it. As we zoom in even further, we're moving very slow. We're moving at 458. I can't see. Oh, there we go. All right. Yep, you see it is turning. We see our nav ball. It is doing its dance. High above. Where is Kerbal even? There's Kerbal. Oh, look at that. And there's the moon far away from us. Wonderful. Bringing our periapsis down into the atmosphere. Hopefully, we're running very low on fuel, so it's iffy. Let's see. How did we... Oh, no. Oh, no. That may be an issue. We are not going to hit the atmosphere with the amount of fuel that we have left. We have undersupplied for this mission, which is worrisome. And I had a brief internal debate about whether or not to revert this, but ultimately decided that no, that would be cheating. While we will not be able to enter the atmosphere, we do have our satellite, or our low-range dish, which means that we can transmit the science that we did collect, even though we will not be returning to the planet. So we are going to... Oh, nope. I think we are still in time warp, so we can't... And yep, just waiting for past me to notice. There we go. All right, review the data, and we will transmit all of our remaining science, which of course means that these experiments will be inoperable. And we jump around, grab the mystery goo, transmit all of that, grab the mystery goo from the other side, and take a look at the temperature. And unfortunately, that one we're not going to get any more data from transmitting. But at that point, we will go ahead and call this satellite decommissioned, or call this probe decommissioned, at which point it will continue in its current orbit, eventually encountering the moon again, which may fling it off into space or may bring it back to the planet. We simply don't know. But at this point, we will go ahead and call this a mission well enough done, and let this go ahead and fling itself off into its high orbit. And we will have to jump back into new and bigger and better things in the next episode, so I will see you then. Cheers.